Alright, hell yeah. So this is the JEE 2024. This is question 10. This is probably, you know what I mean? I don't know. This is like the math section. I don't know if these are easy or not, but this one was said, someone was saying, hey, you should try this one. It's one of the easier ones. And I did it. You know what I mean? So, and it only took me, I would say, less than half an hour, probably about 10, 15 to 20 minutes. But anyway, so it's just like, how do you solve problems like this? My brother is a 7th grade math teacher, and he does problems like this kind of at the beginning of the class every day. And, he just makes the kids, find different ways to do things. So we have to sum these numbers up, and holy hell, this number has 98 digits there, and then plus 2. It's got 100 digits, you know what I mean? So now what? Any of these problems, you should just start summing. So that's what we're going to do. We're going to do this about 4 times. So we're going to add 77 to 757. Cool. And you might make hella mistakes, but we got 12, 13, and then we have 8. Okay, sweet. So let's add the next one. That's going to be 7557. And we're going to have 13. And we're going to have 9, and now we're going to have 13, 8. Cool, and we're just going to do this probably 2 more times. And this is literally what I did. I just wanted to see if there was any, pattern, and it didn't seem like there was, but it was useful. Having this just written down was very useful for me to kind of solve. So these add up to 10, so we have 15, carry the 1, and we have 8, 9. And then we have, we're seeing more of a pattern at the end, and so that's kind of what I was noticing, and that kind of helped me finish this problem off and solve it. So 7, 10, this is going to be 15 again, this is going to be 9 again, sweet. Okay, so now we are definitely seeing a pattern. And we can do this one more time, but that's it. Last time. Okay, so we have 14, 5, and then this is 10, this is 15, this is 9, this is 13, and 8. Sweet. So what we notice, or what I notice, is like, hey, it looks like these last digits, these probably last digits aren't going to change. And it's even getting worse, you know what I mean? So if you notice, like right here, this goes from, even though we have another tens place, like this has 1 extra digit. But even, these zeros, it looks like this is going to get, so yeah, this is going to stay put. So for sure that's going to stay put. And then what I got confused about is I didn't notice this. I didn't notice this 99. I just thought, whatever this was, I thought this was that. So sometimes my cognition is not very good when it comes to reading problems. I'm just going to make up stuff while I read them. And makes for good videos, because I can just solve everything else, but not when you're doing something like this. So heck yeah, so this number is different, and so when we sum these up, this number is like, hey, the next one in the series, but we haven't summed it. So that's what this number is. And so so now what we're going to do is, so now we kind of know, let's learn something about this number. Because let's say I just have 1 times 10 to the 1. That's going to be a number with 2 digits. Okay, sweet. And so how many digits does this have? It has 98 digits between. This has 100 digits. So that's going to be 1 times 10 to the 99. You know what I mean? Because if this is, doesn't that make sense? You know what I mean? Because we'll have, you know what I mean? This gives you that digit, this 0, and this is your digit in the beginning. So that worked for me. So this is a 100-digit number, and so now what we'd have here is we would have something like this: 7 7.555, that's good enough, times 10 to the 99. And then we're going to add, hey, just add the next column, just the next number down. That's going to be 0.755, good enough, times 10 to the 99. Times 10 to the 99. It can still be times 10 to the 99 because we just moved this. It's the same thing as 7.55 times 10 to the 98, but visually it's just nice. And then when we add these, we're going to get 0 there, carry the 1. We're going to get, and maybe we should carry this out just a few more digits. So we're going to get are we going to add these, or what the hell are we doing? Oh, we're gonna add them. Yeah, we're gonna add them together because we kind of want to know what this number is. And this last term drives. And then the next term, you could probably just add those two and call it good. You're pretty much close. And so that's pretty cool. It would be like adding if I said, hey, a football field. I don't know why I'm going that direction, but let's say you're measuring your room and you're like, well, I think my room is 12 feet, but maybe a tenth of a foot. It might be 12.1 feet, but then maybe it's or maybe just 11. Or start with 11 feet, but maybe it's 11.1 feet. But then maybe it's 11.11 feet. Okay, like now you're not even saying anything. 11.11. And so that's what these are. I mean, you would start as you'd be like, hey, let's say 11 point, and then just do this 100 times. So this series starts by saying, hey, I have a number that's just like 100 zeros and a 1. Okay, and then I'm going to add it to another number that's like 99 zeros and a 1. And then I'm going to do this. Well, who the hell cares about all this? Is just nothing. And even these 3 digits, that's probably all. And that's three digits, you know what I mean? That's all you need in physics. For most all science problems, you're only interested in about 3 digits. Okay, so let's do this. So this is going to be 10. This is going to be 11. And then this is going to be, I guess, 11 again. Oh, whoa. Is this what we're doing? Oh, shoot. I feel like I'm not going the right direction. But anyway. And then this is going to be 8 plus 7. That's going to be 15. And then we have 8. So we have like 8, 5, 1, 1. Okay, sweet. So let's add the next one though, which would be so this gives us 8.511 times 10 to the 99. Now the next one's going to be 0.07555 times 10 to the 99. And if we do that, I guess we can only go to this. We're going to add these, so we have 5, we have 6, we have 8, and then we have 5 and 8 again. Okay, sweet. So let's do that again. So we're going to go, so here's our decimal. We're going to go 0.00755. Okay, I guess we're only going to add this one. So we have 10. This is going to be 14. And then we have 8, 5, 8. All right, sweet. Can we do it like one more time? So we're going to go 0.00755. And I should have been probably keeping track of these 5s, but it looks like we have 8.5847. Cool. And I feel like I even made an error. Hopefully I made an error because it's not supposed to come out. It's supposed to come out like this, 8395. And we're close, but that 5 is messing with me. Yeah. I made a huge... This is just 1213. So sorry about that. Yeah, that made it probably look real bad. Anyway, so this number is approximately 8.385 times 10 to the 99. And so this is this number. But now this number is 75.555 times 10 to the 99. It's 7.5 times 10 to the 100. You know what I mean? That's this number. Because we would have 7.5 times 10 to the 100. That's going to be a number with 101 digits. Cool. And so we would have 99 plus 100 plus 101. So we have a check on reality there. So now what the problem says is, well, I mean, the first aspect is like, it makes sense that this is bigger. Because I was just like, well, if this is small, there's no way. Like, if this was that 98 term right here, you couldn't add a number that was less than 3,000. And then what would you divide? These are natural numbers. I had to look that one up. Natural numbers are 0, 1, 2, 3. Okay, cool. They're just positive integers. All right, hell yeah. So, yeah, you wouldn't be able to add, I mean, if this was this 98, 7 with 98 fives and a 7 right here, plus something, you would have to add, to get the actual, to add up all those other numbers. Well, yeah, so that threw me for a loop. But obviously, it's like the next number in the series. So it's like it's way larger. But actually, it's not way larger. It's just larger by, now you're just comparing 75 and 8. Okay, so we're just gonna divide that. So that's all I did. I did this, and I was just like, well, where do I start? I actually started by dividing by oh, am I doing this right? Oh, my bad. I'm going the wrong direction. Okay, so this number is the larger number, and what do we need to do? We need to, oh yeah, we need to divide that number by 8. Oh, damn it. Why am I tripping out on this? Oh, sorry. I'm just, because I've already solved the problem, I'm probably just getting ahead of myself. So the sum of all these numbers is going to be this. It's going to be 8.395, you know what I mean, good enough, times 10 to the 99. That is going to be this number. This number is way bigger, and so, forget this term for a second. And so we're just going to take this bigger number and then divide it by, we have to divide it by some number to get this. And so, oh, never mind. I think maybe we divide it by 9. Oh, maybe I'm tripping out. Okay, so we have 7, 5. Is that right? Is this number right? Well, yeah, no, duh. Yeah, we have this. Yeah. So we have 75. Maybe I haven't done the problem 100%. I just got excited and I'm just like, oh, hell yeah, we got it. But yeah, we're going to divide this by some number, and hopefully we get this number. You know what I mean? Hopefully we get 8.395. So what would we do? Because if we divide this by 9, this would be 8. Yeah, so yeah, oh yeah, so I was off. Yeah, I think this is going to be 9. I thought it was going to be 8, but maybe I didn't think that. But anyway, so heck yeah. So if we 75 divided by 9, or basically more like, hey, 9 times 8 is 72. We're going to have a remainder of 3. And then yeah, 9 times 4 is 36, but we only have 35. Oh yeah, I'm glad I kind of did this wrong, got excited, and then just started filming, because, no, yeah, we messed this last part up. So now we're doing this last part right. So we're going to have, we can't divide by 35 by, so we have to do this 3. So now we have 9 times 3 is going to be 27. We have a remainder, I would imagine, of 8. Because we, but yeah, we have a remainder of 8. Okay, and then bring down, so now we have 85 So we can multiply. We can't multiply by 10, but we can do 9, and we'll have 81. 81 minus, so we're going to have a remainder of 4. And then, sweet, 9 times, this is going to be 5. And then, booyah, we are so check on reality that this number is for sure 9. And now, I mean, this is the trick. This, you're just like, oh, shoot. Now, what do we add to make it a perfect? Like, how would we figure that out? And, well, obviously, the problem, oh, this is fascinating. And maybe it'd be fascinating if I spent more time, because, like, hey, this is like, locked and loaded even after like 4 digits. So it's just fascinating that maybe these next digits is 0, 0, 0, 0, all the way till the last digits. But I guess, so yes, my value for this one is just a straight guess. It'd be sweet if I was wrong, though, and I could figure out, and there was something extra cool about, figuring more about this number out. But what I was, if you divide, oh, no. There it probably is, because I thought this was 8, and then you couldn't divide this sum by 8 if it was odd. And we have, and to count the number of terms here, yeah, this is a bummer. So I think I might have to end the video, maybe come back to it in 2 parts, but I for sure got N, so I get partial credit, hopefully. And then, yeah, I messed it up the first time through. I thought this was going to be 8, and then how many of these are there? Like, hey, this is the number 1, because that's what they're saying. There's 98 5s, so this is 2 5s. And then so if we have 1, 2, all the way up to 98, that's going to be 98 of these terms, and then we're going to have 1 of those. So we're going to have 99. And basically we have 99 terms that are all odd, and if we added 1 plus 1, that would be an even number, but we have an odd number. So 1 is odd, 1 plus 1 plus 1 is odd. So yeah, so I thought it was just like, oh yeah, we're just going to add 1. But now I have no idea. Oh, and you know what? It wouldn't matter anyway, because there's plenty of numbers that are even that divide by 9. So I would imagine, yeah, I would imagine, ah, shoot, this is tricky. Yep, so I think I'm actually not going to do this on camera, but I'm going to play around with this, and I'm going to start from this upper end and go the other direction and see if I can see a pattern. Because if you just start adding these, hey, this 1's digit's always going to change on you. But if you go the other way, maybe you can kind of see a pattern there. So yeah. And if this is a video and I just got half credit, you know what I mean, I might give up on this. But anyway, so hell yeah, we at least got half of it. I was pretty excited about that. So, and if there's no more to this, there's no more. So thanks for joining me, and that's a video. Alright, hell yeah, so we're back. And man, I tried to add from the end and from the beginning and to see if there was any sort of patterns, and I was just like, you know what I mean. And then I just looked up online. Well, I was just curious about this, if we are, I mean, obviously if we're dividing by 9, that is like, hey, that should give you a clue. And then what's the rule for things that are divisible by 9? The sum of all the digits have to equal 9. But then I was just thinking, well, how the hell are you going to add up all those digits? But here's a cool rule too, and I was just like, I didn't even know this really existed. But if you're like, hey, if we add 9 plus 18, both of these are divisible by 9. So if we say, hey, 9 is divisible by 9, and 1 plus 8 equals 9, and that's divisible by 9. And then if we add these two numbers, 9 plus 18, that's going to be 27. And heck yeah, we get another number that's 2 plus 7. and that follows the same rule. So if we do 81 plus let's say just 27, we get 8, and then 8, 9, 10, and then heck yeah, we get a number when we add them up. 1 plus 8 is equal to 9. And then I'm glad I counted the actual number of terms in here, because it still took me a while to figure out what to do. I think the first thing I did was I just started adding up all the columns to see if there was a pattern, and hell no, there wasn't. You know what I mean? If you put all these numbers, the first one, you're going to have, how many of these are there? There's going to be 98, because this is 1, 2, up to 98. So there's going to be 98 of those terms, plus this one. So you have a 99. You're going to add 99 terms. And then so the ones column is going to be 99 times 7, and that's going to be 63. And 63 plus 6, that's going to be 69. And then you're going to have 693. But yeah, you know what I mean? The ones places, yeah, there's no pattern. So then I had to switch to actually just get the right answer. And I was glad I stumbled across this, because I was just like, well, let's say we add up this, and no duh, this happens a lot with any of these problems, is you always add the first term and the last term, and usually, you know what I mean? It really doesn't help you find the sum, or the solution for the sum, but it does help you, because let's do that, and we'll find that is going to be a number that's divisible, that passes this test. When you add up all of the digits, they are the sum of all those digits are divisible by 9. So how would we add this? Well, we're just going to add the last two. We know this is a hell of a long number, but we're just going to add the last two. We're going to say 57 plus 77. That's going to give us 14, and then we have 134. Okay, so and then what would this number look like? Well, it would be 7, and then we no longer have this as a 5, that's a 3, and then this next term is a 1. So we don't have 98 fives, we have 96. 96, and that was a pretty good way of just visually doing that. So we're going to have a 7, and then we're going to have 96 fives, and then we're going to have 1, 3, 4. So heck yeah. So even just right here, we have enough information to add these. So we're going to, the first thing to do is 96 times 5, that's 30, that's 45, plus 3 is 48. So we're going to have 480, or what I should more say, if we added up all of these 5s, we would get 480. We're going to add up the 7, and then, whoa, sorry about that. And then we're going to basically add up those 3. The 7, the 480, and then the 134. Never mind. Are we doing this correct? Oh, yeah, no, we're not doing it correct. So all of these 5s add up to 480, but then we just have to sum the digits. So it's 7, 1, 3, 4. I'm glad I caught myself. So now when we do this, we're going to have these add up to 10, and then we have 15. And then we have 9, and then we have 4. So check this out. 4 plus 5, those are 9. And then we have 18. So we have 4 plus 9 plus 5 is 18. And then those two digits, 1 plus 8 equals 9. So hell yeah. Now, this is only the first part, because what we need to know is what do we need to add right here. And it's because we have an odd number of these things. When we start to add all these, well, and I have, I just got to the part where it's just like, okay, this will lead to the solution. But now we have to figure out what the middle term is. So I think the best way to do that is do this. We'll do 77, and then we're just going to do 757, and then 7557. Cool. So here's our even term. What's our middle term? Well, it's going to be 2 divided by 2. So if we take this number, divided by 2, we get 1, which is a 7 with only 1 5. Cool, let's do this a couple more times. So we got 7. I just don't want to make any mistakes. 3 5s. And then we have 7. We got 4 5s. Cool. So if we had this, what's the middle term? It's going to be this 2. And okay, so I think we have a pattern that I can be assured of. We're going to take 98 divided by 2. And we're going to get, 4? 1, 9. So we get 49. So we're going to have 7 5s, but 49 of them. Cool. And then a 7. And then let's add up these. So we have 49 times 5. That's 45. 24. So we have 245, and then we have to add the 7s. So we're going to add 7 plus 7, which is just adding 14. So let's just do that. Add 14, right? And we get 9, 5, 2. And I might have messed this up, but this should not add up to 9. 5, 6, 7. And so we have 2, 5, 9. And we can only add. It doesn't say subtract. You know what I mean? So, what does this add up to? 9, 10. Sorry, I'm bad at this. That's going to be 10, 11, 16. So this adds up to 16, which adds up to 7. So we're off by 2, but it doesn't really work. I don't think it works that. Maybe it does work that way. But let's go 260. This is going to be 8. So let's go 261, and that's going to be 6, 7, 8, 9. So sweet. So we have to add 2. So I would say n is 9 and m is 2. But I would go back and just make sure I double check this, and might as well do that. So I'm really confident about this, but we just want to double check. This is going to be 45. Okay, I'm pretty good with that. 24. So 245 plus 14. Okay, so now we have 9 and 5 and 2, so we have 259. We can't subtract, so we, and so it's just fascinating that works. If you had the number 1 not divisible by 9, so you would have to add, there's a possibility you would have to add up to 9. Because if you went the other way, let's just go the other way. So if we had 258, we have 7 and 8, that's 15, that's 6, that doesn't work. 257, that's going to be 14, that's 5, that doesn't work. So then 256, so you're going to have to do this 9 times to actually, you know what I mean, there's going to be 8 that are not going to work. That makes sense. Okay, this is kind of a cool little rule. So we have 11, 12, 13, that's 4. That does not work. So 255, this is 10, 12, that's 13. That does not work. 254. They made the problem pretty nice where you don't have to do this like 8 times to get like the right one. 254 is 5, 6, 7, 8, 9, 10, 11. That doesn't work. So 253 is, and we might already be pretty close, because what's 261 minus 9? That's going to be 252. So 253 should not work. 8, 9, 10. So 252 definitely works. 5, 6, 7, 8, 9. And if this was minus, so it's kind of fun to do other problems. You know, for the next year, they could just turn this into a minus. And then you would have to say, well, it would be, you would have to, 252, what would you have to minus? Because we get 259, and to get to 252, you'd have to minus 7. So sweet, and that makes sense. We're going to add 2, so this is the answer. And I haven't looked at the answer, so I'm just, but you know, these problems are so difficult that when you actually stumble across how to do them, they're weird because like there is only one answer. It's really hard to make mistakes on problems like these. But yeah, because of that. All right, so I think we explained it. And even with the negative, that was pretty good. That would be a good one. Just for next year, just turn this into a negative and be like, whoa. Okay, so So hell yeah, so I'm pretty satisfied with this. I would have never thought I could do anything like, I hate puzzles. I really do. I like math, I like physics, I like science, but when it comes to I hate puzzles. You know what I mean? So there's an aspect of math that's just like, it's not for me. But it's just kind of fascinating that if you learn all the little tricks of the trade, that yeah, you throw them together into a problem. I think for me, these are easier than like sitting down with a little puzzle. Those drive me insane. But at least these, you can kind of read the room and figure out what the actual question writer, is trying to get at. And so, yeah, there is that where it's not so much of a puzzle to me. But anyway, more just learning about stuff you already know, that you've already done. And it's good problem solving too. I like it from that perspective, how like the simplest thing to do is just start adding numbers and then seeing patterns. And that happens a lot. So this was a good one. Alright, so hell yeah, thanks for joining me, and that's a video.